Welcome everybody to the next IMAUG meeting. Derek, are you recording this one?
Yeah, I just kicked off.
There's like, sweet. Make sure you guys connect with us. We're on Meetup, Twitter. All of our meetings get posted on YouTube. If you have any questions, feel free to reach out to any one of us. We'll hopefully get back to you and help you out with any questions you have. Our schedule today, we're going to be doing application monitoring, and that's going to be presented by Cory Gideon and Matt Braafhart from Sogeti. And then we're going to be done for the year. Next year, we're going to be kicking it off with Mitch Sellers from Iowa Computer Gurus, and it'll be Azure DevOps for .NET Core and then build and deploy. And then we have something working out for the 2nd of February. Just kind of check back and see what that looks like.
And it's probably good to mention, Alec, that we are looking at moving to a every other week instead of once a month now.
Yeah. And if anybody in the community has a topic or anything that you want to speak on, it can be anywhere under the Azure umbrella. We'd be more than happy to talk to you about it and see how that fits in our schedule. So even if you're not looking to do it like in January, feel free to reach out and we can schedule stuff as far out as late in the year or whatever else.
Yeah, if there's any topic you're interested in, let us know. But if you're doing something at your company with Azure that you want to be able to show off, by all means, step up and let us know. We'd be glad to have other people showing kind of what they're using Azure for and give a presentation on
it.
Yeah, that's what I was going to say, Derek. It's helpful for people in the audience to, or people that are attending this, to give us feedback on what you want to hear more about, because between the 4 of us, we have quite a few contacts throughout the Azure ecosphere, and we can line up a speaker on any topic you could think of in Azure. So anything that you're curious about, want to learn more about, don't hesitate to reach out.
Yeah, and if it's a topic that your company might be using, feel free to reach out to us. We can tell you. Just because your company is using it, you might think it's simple and easy, but you might be doing something cool you don't even realize. So if you just want to connect with us there too, just let us know. And again, here's some free learning resources still out in Azure, Pluralsight, Microsoft Learn, Cloud Training. All these links have free courses. They're pretty great to use if you want to get started in Azure, if there's a topic specifically you want to dig in on your own. And with that, I will introduce today's sponsor, Sogeti. And Matt will be speaking from them, and so will Cory. And we're going to go through the second part of talking over monitoring the application that Matt demoed last time. So with that, Matt, I will hand it over to you.
All right, thanks, Alex. So yeah, Sogeti, real quick plug for Sogeti Capgemini. Sogeti is part of Capgemini. We are the technology and engineering division of Capgemini. Capgemini is a global consulting services business management firm similar to Pricewaterhouse, Accenture, Cognizant, etc. Although we like to think we're a little bit better. And Sogeti is more of is a subsidiary of Capgemini, where we have more of a local touch to our markets globally. So we'll have a more local presence and consultants in a particular geographic region. And we do, all consulting services. Azure is just part of what we do, although it's a big chunk. And Cory Gideon and I, who's going to be presenting to, are a big part of that chunk. So that's my plug for Sogeti. We're going to be doing a drawing at the end. Whoever's left over, we'll be giving away the new Echo Show 5 and the new 4th Gen Echo Dot. So 2 lucky winners on that. So stick around. I'm going to share my screen. There we go. Okay, so last month, we did a presentation on serverless enterprise applications in Azure. So using the different resources in Azure that can be leveraged to deliver a full-scale enterprise application at scale. And part of the advantage of, in addition to all of the other things that Azure has to offer, one of the main advantages to putting your applications in Azure is the fact that you can leverage the built-in monitoring through application insights, Azure Monitor, without needing to implement heavy monitoring and logging, and have a SWAT team of operations people just to make sure your app stays up and running. So I wanted to just kind of start out this presentation with a recap of what we talked about last time, just in a high-level discussion regarding how we architect applications and what the platforms are that we're targeting in Azure, at least from a more traditional common scope, at least. We're not going to go into detail on analytics and machine learning and artificial intelligence type of things in this discussion. This is more for traditional application development, web application development. So, iOS apps, potentially web apps, React apps, Angular front ends with SQL Server backends and API middleware. So the platforms that are the main pieces that we think of when we're thinking of architecting something in Azure are the infrastructure as a service, which would be your traditional virtual machine infrastructure where you would stand up VMs to replicate or be similar to what you would have had traditionally on-prem. So some of your traditional monolith, in-tiered apps, Java apps, .NET apps, third-party products, purchase software, those types of things would run in this infrastructure as a service type architecture, which is mostly consists of virtual machines, right? And then the next step from that would be your platform as a service. So in the platform as a service, we start to abstract away some of the traditional server concepts and replace that with the app service plan or containers or Kubernetes services, right? And then we can start to architect applications that are more microservices in nature, still support an in-tiered style architecture, but it gives us the ability to do some hybrid stuff and some migration stuff and some replatforming of old legacy systems into a more cloud-native style of architecture. So that's kind of the first step of your move and the major shift in architecture of applications. The next after that would be sort of the backends as a service as part of that, but the functions as a service. And that's where you truly get into your concepts of serverless and microservices. There's some overlap here between what AKS, Kubernetes, and containers can offer and what the functions platform can offer. And I won't go into detail on Kubernetes here because that's definitely a topic for a whole meeting, a whole discussion, and something that will line up in the future. But the functions as a service has sort of this monitoring and application insights cooked into it. So you really don't need to lift any fingers as a developer to make that happen and to monitor your app and to really dig deep into the analytics of what's happening when your application is running, even in production and real time. And then the backend services are your SQL Server storage accounts, Cosmos DB, your NoSQL type databases, Azure Table Storage, static website hosting, and then integration services such as Azure Data Factory, which again, that's a topic for a whole separate meeting. So here's what we think of when we think of our standard, traditional in-tiered architecture on virtual machines, either on-prem or in Azure on VMs, where you have this, multiple concept of tiers, where you would maybe separate your web front end from a business layer and maybe a data layer. Maybe you have multiple data layers, multiple business layers, and then front end with a traditional web application, whether it's MVC or even some of the SPA frameworks. Then you migrate into, so once you get there with Azure, right, you want to start taking advantage of what Azure has to offer. Some of the serverless concepts, the platform as a service, the function as a service. You can start to run your legacy APIs or web applications, along with starting to carve out slices of business functionality into these microservices, and start to slowly migrate away from that concept of monolith. Here's an example of the application that we're going to do a demo of, or that we did a demo of last time, that we're going to use to demonstrate application monitoring in the Azure portal. So what we did was we built a single page front-end application using React that connects to Web API middle layer or microservices layer using Azure Functions, which then backends in our case, it was a SQL database, not Cosmos DB, and using the static website hosting in the Azure storage account. You can serve up a SPA web application where everything is sent to the client, cached on the client, and you're just simply doing HTTP posts, gets, puts, deletes, whatever, back and forth to this API layer. And then, of course, you can secure that with Active Directory or OAuth or any kind of authentication mechanism. This is just a diagram of sort of a microservices approach where you're breaking out your functionality into multiple functions layered. So you have one function that maybe interacts between the web server or between the website or iOS app or Android app and the database, and then maybe you have some triggers on your database that call some more functions, and then maybe there's a queue behind that, and it can keep cascading using message queue, message services, service bus, that kind of thing, where you truly have an asynchronous disconnected architecture. And here's another example of that, where we actually are using Event Grid. So your front end is disconnected from what's happening on the back end processing through the concept of event queue and message bus, where it's first in out, or you don't lose data because everything's just stacking up on a queue, and it's asynchronous between your back end and the client. Here's another example of the queue architecture. So you would have a front-end app that's writing to a queue, and then your function picks up from your queue and writes it to your database, whatever that might be. This is becoming a more common architecture that it's very good for scaling up and scaling down, and ensuring that you don't have data loss, and being able to potentially span across regions geographically. So, okay, that was kind of a rough recap of our application architecture and what we're doing in Azure. I'm going to send out a link to everybody to this actual application that we created. And what I want you to do is fill out the form and submit it. So this is a completely serverless application on Azure, hosted on Azure. It's an Angular front end, which calls the API layer, which is the Azure Functions, which calls a SQL database in Azure, and the activity of you guys doing this will generate some data for the next part of our presentation, where Cory can go through the application insights and monitoring. So on this survey, just pick one of these surveys. It doesn't matter which one. Let's do Iowa and answer the questions, and then submit your response. You should see a success message at the top of the screen, in theory. No.
Hey, Matt, you want to pop that link into the chat window? Just make it easier.
There we go. Yes. Yeah, I was waiting to make sure
Okay.
it worked. So yeah, so it does work. Put this in the chat.
Hopefully everybody can see the chat window.
I'm trying to find the chat window. There it is. There you go. Okay. Okay, so yeah, as you guys are doing that, I'm gonna show you real quick the portal resources that. This is kind of a recap from last time, but I'm going to show you all the resources involved with making that application work. Then I'll turn it over to Cory to go into the monitoring of that application in real time. So I have two static websites. One is the one that you guys are hitting, which is a public-facing storage account, and that's this. Then I also have an admin interface where I can go into the application and create surveys and add questions to the survey. So that's this storage account. And then I have a function app service, function app, which contains all the REST methods to support each one of those. One's for the admin and one's for the user. And then as part of when you create a function app, it automatically creates a service plan behind the scenes, just part of the way it works. And then it also needs a storage account to host those. So you'll see when you spin up a function app, you'll see three resources. You'll see a function, you'll see a storage account, and you'll see an app service plan. So that's what those are. And then we have a SQL database. Again, when you try to create a serverless or an Azure SQL database, it's going to automatically spin up a server because it needs to have the concept of the server for the database to run. And then when you create an Azure function, you can choose to use application insights and automatically hook it in. So each of the Azure function apps is going to have a application insights resource tied to that. So that's it. These are all the resources necessary to do this application. Now I'm going to turn it over to Cory for him to start drilling into monitoring. So hopefully everybody's able to hit that site. Let me know if you can't or if you're having issues. Cory, do you want to take over the screen sharing, or do you want me to keep rolling?
Why don't you keep rolling with the slides?
All right.
I'll take over in a bit. So, Yeah, as Matt said, went over the architecture of all the different Azure resources we had to create in order for this app to run. And each one of those resources, especially the functions, are hitting a different app insights container. So just go from a high level what app insights is. So application insights it's an extensible APM service. So pretty much what it's doing is, well, what you have to do is you install this small NuGet package into your project, and then a lot of your functions are already using like an iService logger object. So this logger object is what is taking the events from your application and then writing them to your app insights container that is configured in a application insights.config file using the instrumentation key. The different levels of logging that you can get in your app insights is, the information level, the trace information and trace. So those are your lower levels. There's debug, which is the low, which is low as well. But then there's your warnings, your criticals, and your errors. And App Insights will automatically detect these performance anomalies or detect these issues and write them out. App Insights also supports multiple languages on different platforms. So you can have a Java project, a Node.js, a Python project writing to your App Insights containers. And then you can also monitor your mobile telemetry for Visual Studio from the App Center. One thing to be careful of with App Insights is it is a pay-as-you-go service, and you pay per gigabyte of storage. So large traffic sites like your e-commerce sites, like especially around this time of year, or financials around tax season, you can be getting hit a lot. And if you have your trace, your informations, or your debugs set up in production, you could quickly run up a huge bill. I remember reading a case study a while ago where they didn't take out their log information. It was a e-com site, and they didn't take out their log informations. And in a month, they racked up, I think, around a $10,000 bill for the storage, because your default retention they had a set default, which is a 90-day retention of keeping these events. So that's something to be conscious of if you're expecting high traffic in your application. Make sure you're paying attention to the level of logging that you were doing, as well as your default retention rate. There are also some ways that you can do, so Matt, if you can go to the next slide. Okay, so here's just an idea, example of how application insights is set up to work. So you have your web pages, your client apps, and then your web services and the dependencies. All of these are writing out to your App Insights container or resource on Azure. And it's great to have that information out there, so you can, as a dev or support individual, you can go out there and view the events through App Insights, but that's not necessarily useful or usable for, say, a business, someone on the business side who wants to know how many requests are hitting this area, or if we want to do some more advanced logging. So you can also plug in Power BI to pull information out of your App Insights. And then if you wanted to do some a different route, you can also App Insights also has the ability to create a REST API where you can get it programmatically. So if you want to connect multiple App Insights containers into a dashboard, for instance, you can get them hooked up via REST APIs and pull them into your dashboard, so you have a good holistic view of how your system is running as a whole. And then another way, if you wanted to do some more advanced monitoring, you can also use Jupyter Notebooks. If you're familiar with Jupyter Notebooks, it's just it's a good way to query data, query information out of a system. We used to be able to use notebooks.azure.com, but that is being retired as of January 2021. So there's other ways you can do this. You can do Jupyter Notebooks in VS Code, and you can also currently GitHub has a project called Code Spaces, which is in beta. All right, next slide. So another way to cut down on what you're going to be pulling into your app insights is by sampling. So this sampling is just a way that you can get specific pieces of information, or only get it every request that's coming in. You can get it on a specific time. Or there's also a dynamic way you can set up sampling, but sampling is just an easier way to reduce the amount of traffic and amount of writes that you're doing to your App Insights storage. So it's just another tool that you can use for reducing the amount of data being written to your storage.
Yeah, especially if you have super high volume applications, and if you have 10,000, 20,000 users, and they're all gonna, if you have a program flaw, all 20,000 users are going to be generating the same error in the same event. So there's really no need to report that 20,000 times. So this concept helps alleviate things like that, so that you're not just creating tons and tons of log traffic and taking up space when there's no point, right? It's like traditional Windows event viewer or event application events in Windows event logs, fills up the logs, servers crash. It always is causing problems. But so this concept kind of helps alleviate that problem, where there are cases where I need to see exactly what that user was doing, exactly what that data was, because they're getting a weird error that I just can't track. But that's not what this is for. It's for the fact that you've got an obvious event that's triggering thousands of times. I don't need to log every one of them. They're exactly the same. Sorry, Cory.
No, thank you.
No problem.
All right. So we'll go on to the next one. So Azure Monitor is another good way to just get specific information on, say, request rates, response times, and failure rates of requests coming in, as well as your user and session counts, host diagnostics, performance counters, things like that. One key way that Azure monitoring can be used is for setting up your auto scaling rules. So if you're getting a consistent response time or failure rate, or so say we'll get a consistent response time of 2 seconds. We might want to then set up a rule that, okay, we're hitting this response time for this sustained amount of this sustained period. We need to spin up some more containers, some more of our functions, or more Kubernetes clusters, so that we can alleviate that load. And then after a while, we can have those automatically shut down. Just kind of it'll take the load off of your ops team from having to go in and get a call in the middle of the night, have to go spin up another instance, wait for the traffic to die down, then spin it down. It's just with monitoring, you're able to just set those rules up and then be good to go. You can also do this with your doing alerts. You can set up an alert to if you're getting over the past like hour, you got 10 server failure errors, so 500s. You can send out an automated email or SMS message to a group of individuals so that they can go out and address that issue. So this will prevent your customer from having to call into a help desk, a ticket being created, then on call being contacted. Just cuts out that middleman, goes directly from the application to the dev team so that they can address it. I can show some of that later on in the portal.
Cory, are you gonna you're gonna drill into some of that, right?
Yeah, I'll drill into monitor, auto scaling, alerts later on. All right, next. Okay, so the last last things I want to talk about is before I start showing the portal is your App Insights telemetry. So this is a good way to get the idea of the response time and the way that you can understand what your stack is doing, find out the dependencies of your application. So the request is generated by your application, and the operation is the threads of the execution that processes that incoming request. So your application again is that's our function app in this case, and any exception that might be thrown will be thrown from here. But then this application is also writing out your traces, your events, and then your metrics. So we can understand, by looking at the metrics, we can understand how our application, like when our application is getting the most consistent use, how many users are hitting it, and just go on from there. And then also the dependency will show you like a function will have a dependency on a database, and we can see that latency time between sending a request from the function to the database and getting that back. A use case for this that we actually would have had at one of our clients is our AKS had a timeout of 30 seconds, and we had a function that we had Angular UI that would call to a function to get data out of the database, and this was getting upwards of 100,000 rows of data. So one way that this could have helped us is we didn't know if the holdup was from the UI to the service layer, or the service layer to the database layer, or just the round trip, and why we were timing out. And if we would have had this telemetry set up at the time when we were doing the development, we would have known that, okay, we're blowing out our AKS timeouts.
Yeah, and traditionally these are types of things that take a lot of time and effort and involve a lot of operations people, and sometimes you got to get out the Wireshark. And back in the day, we actually had a hardware appliance sniffer that we had to put on the network just to figure these things out. Now, of course, App Insights will tell you before you even know that it happened.
Yep. So it's just another good reason to get to have telemetry set up and understand your dependency trees and your dependency response and request times. All right, next slide.
Oh.
That's right. Yep, kind of talked about this earlier. You trigger your alerts from Azure Monitor and App Insights, and then you can also use log analytics to, like, if you can have an alert write a log to your log analytics workspace if you want to. We're not going to show log analytics today, but that is a really cool and very beneficial tool to have when you're trying to debug or understand the performance of your application. All right, I will grab the screen from you, Matt. Maybe. Here.
Before we switch over, are there any? Does anybody have any questions or comments or anything you can think of? Right, this should be as much as interactive as possible.
Okay. No, if not, I'm going to show you this. So we'll take a look at this App Insights container and look at our, so over the past hour, we'll go 6 hours. So you can definitely, you can check out, just the past 30 minutes, hour, as I'm sure you've seen, of how you can go back and get your historic data. So like looking at our server requests, it was pretty quiet, and then giant request or giant spike, dip, spike. So this, looking at this would tell us that, okay, well, something happened around this time that we need to be aware of. Like, is there, if we maybe got a ticket in at this time from help desk saying 12:30 or 12:25, something happened with or 12:20, we were unable to reach the application or reach the website. We could look in here and see, okay, well, we had 237 requests hit at this time, and then going from here, and then there's a dip, spike again, and the same with our server response time. So we're going pretty consistent, and spike down and goes back up and zeroes out. So we're spiked out at 4 seconds or 4 milliseconds, excuse me, no, 4.43 seconds.
Yeah, and right there's a good that's a good point to comment on. So that 4 seconds, that's that cold start on a function because it hadn't been used for whatever, an hour plus time frame. So there is, like, I think Microsoft guarantees a 3 or so second cold start on those. However, the plan that we are in probably is the plan that we're in. It's the 3 seconds. So you can pay to not have that cold start issue, but it just depends on what you need, what your use cases are.
Yeah, and another thing here, we can see that when we hit our peak of requests, the average server response time was 26.97 milliseconds. So if we wanted to do some performance improvements, or if we were running into issues with responses, we could say, okay, at this time we need to spin up another instance. Another really cool thing is live metrics. So if you don't have if you want to get live, like if you're doing load testing with your users, like on a demo environment, live metrics is a really handy tool to have in your tool belt, because we can now go out and look at, okay, we're watching the metrics, have 30 people go out and hit the application, or if you're doing a slow rollout to a larger group of, like a geographic rollout, if you want to see what your performance is, say if you're rolling out to Australia, this would be a good way to get live information as to what's happening. Where just years ago, before, if you're doing this on your own bare metal servers, this would be the same type of thing as doing a grep on your server logs after turning up your logging.
super cool.
Yeah, it's just kind of mesmerizing to watch the data come in. If we
That
wanted
was-
to find, if you want to find like a specific piece of information, that's what your transaction search is for. You can see here we had 534 requests, 1.7 thousand trace logs in the past hour. This would be a good indication that, oh, we need to go out, turn down our logging on App Insights. Because if this was to roll out to a large user group or a large user base, we would be in trouble because it could rack up very quickly, especially with having a the default of 90-day retention.
And one of the other things to call out is that you can give access to this to developers so that they can go in here, right, without, operations people a lot of times don't want to give developers too much control, but you can give access to developers so they can go in here and see in real time what's happening with the application, to debug it and fix issues. It's invaluable for dev teams to be able to fix their problem.
Mm-hmm. And that's a good point. This is having tools like App Insights and Azure Monitor is just one awesome way that we can start moving more towards a true DevOps setup in our organizations. So we can keep this troubleshooting and trying to figure out what's happening and what's happening with our applications in our team, so we're not overloading the ops teams, and they can focus on what they need to focus on, not tracing log or tailing a log or anything like that. This is also a really good way to test your deployed setup, because we all know that, I think any developer that's been doing this for any amount of time has used the line, well, it works on my local. This way we can get insight into what is happening on a deployed application on the Azure servers. So another way that we used this to help us at our client was we were trying to understand, with that same timeout issue, when we figured out that it was the database and we were using EF Core for the query, we wanted to know what is the actual SQL that query is putting out there, and is there a way that we can put some indexes on the table to help out with that? Would it be more efficient to run a stored proc and such? So we were able to add in some custom logging into our application to write that SQL statement to our App Insights instance, and by doing that, we were able to get that query and realize that no, it's already we already have the indexes set up. It's already as efficient as that query can get. We have to figure out a different issue or a different solution for this issue. So digging into that request, just your standard what you would get from doing like a Postman. So create response, 200. Was it successful? How long did it take? So this is another really good piece of information to be aware of. This request took 13.2 milliseconds. Where are we hitting? Like, what is this going to? And also getting our function execution time. We have custom properties of function execution time, process ID, where this came from, and so on and so forth. Like, this is, like, are we doing gets or posts? Sometimes sometimes a developer might put something as a post where it should have been a get, or vice versa. And we don't know what's happening. Like, oh, by looking at this, it was sent as a post. It was supposed to be a get. Let's go in and change that header on our route and make sure that works. So just there's a lot of information in here.
Derek just pointed out that this full functionality and features of application insights it doesn't have to be an application in Azure for this to work. You can do it in a .NET application running on your own data center on-prem, as long as you tie it into the application insight API.
Yeah, that was a good point. Thank you. I forgot to mention that it's not only deployed on Azure. Solutions only deployed on Azure. It does work with hybrid cloud, and it does work with local development, which I can show you. I'll show later. So it just gives you that really good insight into into what's going on in your stack.
So on that local development, show later, Corey. We have 10 minutes left.
Yeah, I'll go ahead and see if I can get my RDP to actually work.
So while he's doing that, Derek, were we cutting this off at 1? Did we change our meeting format to 1 hour? I forget.
We had 1.5 scheduled for this, but I know you guys have a hard cutoff at 1. So I mean, just go up to your cutoff, and then we can do the drawing after that, and I can answer any questions that are outstanding.
Okay. Let me see if I can find where did it go. Okay, can you guys see my Visual Studio?
It's partly cut off. There we go.
Okay. All right, so this is just a simple .NET Core Web API. Nothing real special, but what I did have set up in here is, if we right click, if you're in Visual Studio, and I have not been able to get this to work on Azure Function. I've only been able to get it to work on Blazor apps and .NET Core web apps and .NET, but you can add application insights telemetry, and this already has it configured. But here we're doing app insights local. If we go ahead and start this up. Starting. You can see after I started it, this little application insights showed up. And I already have 2 requests came in. So this weather forecast /get. So let's just like what we saw earlier. But then if we do customer /1, 2, 3. Yeah, all these new requests came in. Here we go. Update. Oops. Okay. Well, let me try that again. Sorry. If I click on the right thing. You gotta love live demos. And I'll go to, okay, updates. All right, there we go. So we have, where was it? See here that we have some metrics that popped up, as well as our original request. Should made sure to test this again locally. But what we should have been seeing, I apologize, is so unhandled exception. Should have been seeing is the request that would have come in would have shown that I could see that I would have seen that I had some new. I have been able to see that I had a dependency on the database, and by having that showing that dependency on the database, I could have seen what my response time was on that, and let's see what my exceptions. The last hour. Okay, there we go. Okay, so here you can see the telemetry of the request get customer, get ID, or get customer ID called into this dependency. Oops. Oh, well, sorry. But you can see that it has the dependency, and by digging in here, you can find out what that dependency was and how that was built, and you can also see here that it's dependent upon this database server. And then we saw that there was an exception thrown. You can see that this is the exception that was thrown. So by going in, and you can see that by testing this locally, if it could have been any sort of exception, a 404, 403. This one is just not implemented. So by knowing that, it's like, oh, oops, I forgot to go in and actually implement this function. So this is another way that we can get some good information locally in our local development without having to trust that everything is working fine and push it out to a demo or a non-prod environment. Yeah, that's pretty much all I had for this. And here's the dependency. You can see that the duration that it was running.
Cory, were you able to get the? So one of the things we wanted to show was the application insights telemetry in the source code on top of the controller function calls. Were we able to get that to work?
No, unfortunately, this is the only telemetry I've been able to get on my local development so far. I've not been able to get it set up on the functions, get them working on deployed, so I haven't been able to see like the application map or anything like that on the portal.
Gotcha.
That is my thing. That is my weekend project that I'm going to try and figure out.
Yeah, no problem. I just wanted to, because so I've used that extensively, and I don't have a good example of it right now, but I wanted to show that. Find the screen. That this application insights data, if it's set up correctly inside Visual Studio in your project, right above your function call, it will show you that telemetry of how many times that method's been called in the last whatever interval, how many errors it produced, and then potentially where the error is. It will show you exactly the line of code that is causing that error. So again, it's super valuable insight for developers. You just basically do a fetch on your Git repo, synced up with App Insights. You potentially can see where your code is erroring in production if you're on the right branch.
Yep. And yeah, that is something that I wanted to try and get set up for this demo, but unfortunately, time got away from me.
Sure. Yeah, no problem.
You guys want me to show the application map real quick?
Sure. Yeah, go ahead. Take it.
Let me pull my desktop up here real quick. If I can. So one the other cool feature of this is I always like to demo, and I've got a demo portal up. Hopefully you guys can all see my screen. But the application map. So, as you instrument out your applications or multi-applications, say you've got a distributed app, API interface, it will take all those pieces and put it into an application map to be able to show you how you're using it, and then even be able to show issues. So I can highlight some of these things and see some statistics of what's going on with my application. I can click on a node and see a little bit more about it, so I can dig into my distributed app a little bit better and show some of those components and stuff, what's happening with them.
That's awesome. Corey, did you show? So ours does show that, but it's not very complex. It's just a function to a SQL server.
No, I did not show that on ours.
And then the other thing too is smart detection. So I mean, you can set up these. They're built in. You can turn them on or off, and being able to do some smart detection on your app using AI to try to determine when things fall outside of a specific scope. So they'll watch and say, you have a normal 20 millisecond load time on a page. If you see something all of a sudden continue to spike up, 20, 30 milliseconds more, you can create alerts on those based on the smart detection settings.
That is awesome. Yeah, and that application map is something I just am now getting familiar with. That's pretty awesome if you have a large scale app. The one thing, Derek, and maybe you can answer, is that we were not able to get that live telemetry within the code in Visual Studio for function projects, for the function, Azure function template.
It should be able to work. I have to go look at, I got a function app I'm running on a regular basis. I'll have to go back and look to see if mine's, it's been a little bit since I've been into it. So let me go see if mine's instrumenting it out, but there shouldn't be any reason that it shouldn't show that just because it's a function.
Sure. So, yeah, Corey has a hard stop at 1. Corey, if you need to go ahead. Thank you. Appreciate it.
Thanks, everybody.
Thank you.
Any questions from anybody on kind of what you've seen today, application insights in general?
And this was geared, more towards application development. There's obviously a lot more to monitoring going on in Azure. It's a big topic. So Derek and Alec, I do have to break as well. So congratulations to whoever wins the one of 2 prizes. Thank you all for coming.
Yeah, thanks for presenting. We can switch over to that now, and I can spin the magic wheel.
Make sure if anybody doesn't say their name, just let us know, because make sure.
So it looks like Ryan Smith. Congrats. So where did my window go? Is he still on?
Yeah, he's still.
Yep. So Ryan, if you want to send me an email with your email, or Matt, would you like what were the 2 things? We'll give you first pick.
The
show. You have the show? Okay.
So yeah, either send us your email if you want to even pop it in the chat window. We can get that to you.
Okay.
Actually, yeah, I'll need. Okay, we'll probably need a shipping address.
Right.
Yeah, after get the email, we can contact them and get the information we need.
And Emily, for the Echo Dot, are you still on?
Yes, I am here.
Sweet. If you could send us your email, we'll contact you and get that shipped your way as well.
Sure, I'll just paste in the chat. Thank you.
Yeah. Thanks everybody for attending, and thanks for a good first year. We hope to hit the ground running in January, but hope everybody has a good, happy holidays. Stay safe out there, and hopefully it's a little warmer, maybe. Have a good rest of the year, everybody.
Thanks, everyone.
Thank you.